Welcome back to the second half of Lab 2, where we will talk about making engineering drawings in Inventor. In the past video, we wrapped up the topic of part modeling in Inventor, and we walked through two examples where we made solid models from engineering drawings. In this video, we are going to do the reverse, so we will learn how to make engineering drawings of solid models, and we will use our first example for illustration throughout this video. The first step to making an engineering drawing is to open up a new drawing file from a template, which are the file type DWG for drawing. Just like with part files, you can open up an ANSI standard drawing in either millimeters or inches, depending on the units you use to create the part. So it's important to pay attention to which you want to open. Once you open the file from template, you'll arrive at this screen where we again have the tool ribbon at the top and the project browser to the left. The template drawing that we've opened already has a default title block, and we can see in this title block that the default drawing size is sheet size D, which is 22 by 34 inches, and this is probably too big. To change to a smaller sheet size, we can right-click on Sheet 1 in the project browser and select Edit Sheet. In most cases, regular letter size paper, which is sheet size A, should be sufficient for our drawings. However, when you change the sheet size to A, you might find that the title block now takes up a lot of space. You can also edit the title block from the project browser to obtain the drawing format that you'd like. But luckily, we've already prepared a size A drawing template, both in inches and in millimeters, that are posted with the course material. So you can download these drawing templates, open them up in Inventor, and once they're open, you can select File, Save As, and then Save Copy As Template to save them to the template folder. When they're saved to the template folder, you'll then be able to see them as options to select when you create a new file. So you are strongly encouraged to use these templates that we've provided for this course. Now that we have our drawing file open with the correct sheet size and the title block format, the next step is to fill out our title block. To do so, we go to File, and then iProperties, and the Summary tab. Here you can put the part name as the title, so I'll put Lab 2 Example 1 here. You can also put your name as the author, and your MAC ID as the subject. The scale and date will automatically be filled once we place our part views, so let's do this next. We can place these views on our drawing by clicking the base button at the left of the toolbar, and then selecting the part file that we want to make a drawing of. If your part file is already open in Inventor, then Inventor will automatically select that as the part to place, which can save you time from having to find the path to your file in your file directory. Once a part file is specified, we can then choose the scale of the views that we are placing and their style. So we want to use the style with hidden lines for our multi-view drawings. You'll see that Inventor brings up the front view to add to our drawing initially, which we can drag to the bottom left as appropriate, and if it's not the correct front view that we wanted, we can use the view cube to rotate the part around until we get the view that we want. Then we can left-click to place our view, and if we move our cursor above this view, Inventor will allow us to place a top view, and the same idea with the right view and with the isometric view. Once we are done placing our views, we can click OK, and we can always move our views around afterwards if we need to by hovering over the view until a red border appears, which we can click and drag around. Note that when we do so, the multi-views remained aligned, which they should for the multi-view drawing. Now, it's important to pick a view scale that fills the drawing area but still leaves enough space for dimensions around it. If you need to adjust the scale after you place the views, you can always right-click on the front view and choose Edit View to bring up the placement window again. Here, I'll increase my scale to 1/3. And I'll do the same for the isometric view. Note we can also change the isometric view to be a shaded view if we'd like, which I'll show for this example here. Now that our views are placed, the next step is to annotate our drawing, and all the tools we need for this are found under the Annotate tab. Some tools I'll highlight here are the Dimension tool, the Text tool, and the Centerline and Center Mark tools. Here's an example of an annotated multi-view drawing of a threaded rod, and it's complete with center lines, center marks, notes, and dimensions, and we'll add these to our example drawing as well using the tools that I just indicated. I'll start off by adding in all of my center marks and center lines in each of the views. I have to add a center mark for the circular features in the top view, which I can do by selecting the center mark tool and clicking on the circle edges. Next comes the center lines, which need to be added to the front view and the right views to represent the axis of revolution of the part, and also the planes of symmetry for that rectangular feature. I could use the centerline tool here, where I have to select two edges that are bisected by the centerline, like the edges of our hole here, and then a centerline will be added. However, in this case, I know that the centerline lies exactly on the y-axis, so I can go into the model browser, go into the front view's origin folder, and I can right-click on the y-axis to include it as a centerline in the drawing. I'll do the same for the right view, and that should be it for center lines and center marks for this part. Next, we can go ahead and add dimensions, which is much like adding dimensions in 2D sketches for part modeling. In doing so, we should remember our guidelines for dimensioning, which includes dimensioning features in their clearest view, not crossing dimension lines, and providing all dimensions necessary to define the part geometry, but no more. So I'll try to align my dimensions nicely for clarity as well. And you'll notice that when I add diameter and radius dimensions, the prefixes phi and r are automatically added for us. In some cases, we might want to add additional text to our dimensions, like in the case of this round, which is repeated on both ends of the rectangular features. We can add text in the dialog box that pops up when we first add the dimension, where the greater than and less than signs represent the automatic Inventor dimension, and we can put text around this. In this case, because the round is repeated elsewhere in the part, I will put the text TYP for typical after the dimension, so that it can be understood that all other rounds share the same dimension, unless otherwise stated. This is just one of a few common annotations that we might want to add to our dimensions, and we will see some other symbols and hole conventions when making our example 2 drawing. For now, our example 1 drawing is complete, from the title block to the dimensions and annotations. So now we can go ahead and export our drawing as a PDF if we would like, by going to File, then Export, and PDF. Now, it's important to note that your drawing file is linked to the part that you're making a drawing of. So if you make any changes to that part file, those changes will automatically be updated in the drawing as well. And if you want to share a drawing with someone else, you can't just send along the DWG file, you need to send the part file along with it, because again, the drawing file references the part file. So if you want to share your work with someone else, you either have to send the drawing file with the part file, or you can export it as a PDF and share that PDF. So we've successfully recreated our example 1 drawing in this video, and the drawing for example 2 will be completed in an accompanying video. We'll end off, as usual, with some troubleshooting tips that were introduced in this video, namely reminders on how to change sheet size and view scale. And this now gives you the tools to recreate the detailed drawing that you are given in assignment 2, which allows you to focus on the tools used to create the drawing without having to worry about which dimensions to include and where to put them, a task that we will definitely revisit in Lab 4.